Hi, I'm Martin. In this video, I will show you a software I built that is a platform for nodejs to handle data transformations with a drag and drop interface. It's a full stack software, so it encompasses a lot of challenges related with full stack development. From the interface that is really complex, drag and drop, nested interface with a lot of states in how it handles information, and also it has a lot of challenges in the backend to handle all the data pipeline, a lot of memory management, and yeah, there's a lot of challenges involved with it. So I will make a walkthrough the most of the things I think they are important. There's, I think, too much to grasp, but I did this project because I was interested in a lot of projects that have been launched recently that has these drag and drop interfaces to handle some sort of interaction with generative models or some kind of like data approach to connect things. So that's why I started this project, and it's been a great way to like learn about this, and I think at least the software works great and it's a great solution. So let's start with the beginning. This is basically a software that runs different data transformation tasks. At its core is basically a bunch of cron jobs that are running, and on each of their iterations they are checking if there is one task that is like assigned to one of those patterns. That is the solution I'm doing right now. I think there are a lot more efficient ways to do it, to handle any kind of pattern, because right now I'm not doing that. I'm doing this, for example. I'm just having these valid cron jobs, and then I just check them out, and if there is something valid for one of those patterns, I just run it. So I have a pattern here, for example, that could be run each 5 seconds, each 10 seconds, and so forth. I have some other rules of how each one of those runs are executed, but it basically does that right now. And yes, I think it would be a lot more flexible if I use other, like for example, caching strategy. And when I make adjustment to the data transformation, it just compiles a list of like, the use patterns. But right now I'm doing that because I need any more complex pattern, and I'm not testing like granularly like what's the correct way to check each one of those data transformations on each moment. So that is the first part of this system. And to create a new data transformation, just create here a new workflow. Say published testing workflow. So as you can see here, I have a indicator if when the form is being updated, and I use that a lot in this system because most of the interactions are in real time. So yeah, I do this. I have it organized by here, for example. So this is the workflow. So here's the interface inside the data transformation. Here in the top of it, you can find the configuration. You can also configure some pass-in data if you want to inform another model that is calling this data transformation to be reused, and you want to pass through data to change the parameters to do something different, doing the same structure that I do it a lot. And as you can see here, I also use the same way of like monitoring the data is being edited. So if I reload it, you will notice it will always send you to the right place to work, because here you can just like drag and drop the interface and pan, zoom, etc. Here on top you have this bar to set the way it is executed, the process. So the first one is batch size. That is the amount of times that a process is run concurrently. Each time is checked. So if I set it to 3, if time I run it, it will run 3 times at the same time. So it's pretty handy if you want to, if you have some way of randomizing the process. It is pretty useful because it will just make them run like concurrently. So I can set like 50, like run 50 times, like to, if you want to just like test different like sizes of the process, or in a concurrent way, not like in the data being analyzed. So secondly, you have a start timeout. So if you want to set like 100 milliseconds as a delay on each of these batch executions, you can set it to have as big of a delay you want to add. If you want to add a second, you can add a second. Another thing, if you see here in the bottom part of the interface, each time I edit something, it is already updated. So if I update here, you can see this, the 100 and the 1. So it's pretty nice. I set a lot of observers to the interface to make it absolutely work in real time. That it was an important thing for me for this software. Another thing, you can stop the process on error. I normally don't use it because I normally handle the errors inside the workflow, so it's weird for me to use this. I actually haven't used it, not even once. I just use it for testing. I developed it, but it was a useless time doing that. A single shot, it just runs the process the amount of times you say to run. So you say here to 3, it will run 3 times and then we'll stop. For example, we set here in the run pattern 5 seconds. So we'll do 5. We will set it here. We would check the console that it will start running. For example, there is starting the process. 1, 2, and here we can see the third one will start the process, and the interface is actually checking that the process is not longer running, so it stops like in the same interface. So it's really handy to just like check the interface here and see the process stopped. So this is one part of it. And you can also have another like indicator to check how fast it should check this information to see if the process is already running or not. If you need to have something with more like priority, this is really important. So you can set this to 100 milliseconds. It will be more intensive for the interface, not so much because it's just a small HTTP request to check with the API if the process is still running, but other than that, it's like you can just adjust how fast you want it to refresh. So before going through all the specifics of each model, I will show you how they are executed in the runtime. So in the beginning of the video, I explained that I wanted to do a system that could work concurrently and divergently, basically, that each model can go to many different places and could accept many different inputs, and that could also handle pipes and the different life cycles of the data. So this is my approach to the problem. So each module, as you see in this case, has these 4 different handles. The first handle is this one, is the plus sign, that is the input. Here you input information to this model. It has 4 outputs. It has this green one, that is the success one, the red one, that is the error one, and the blue one, that is the always one. So it's a copy of the promise-based request. And also, for example, this is the way this model is initialized. There's a lot of other things that each model can do. So For example, I will take this one. You will see each model has different kind of like interfaces. They are like, they have some common things on top, but they work really differently. So if you check this one, the moment I added it, had all these things. That is the mapping of the things that it's doing for me to know in the interface what I'm doing. So I can do here this, I can set this, something like this, for example. And I will have some information in the interface to know what is happening. So it's just like reference information. So, but the interesting thing right here, so, is that these models can work in different ways. For example, here I'm connecting this model to these two different stores, and there is this logic I explain in detail here in my website, that explains how I use the path building logic to handle pipes. So, for example, this specific, let's get some contents. We created, name it. I should get something. I will make a really lightweight request here, title. So I will use that really lightweight request, and when I do it, I get this. They don't have title. I think I have label. It's the correct way, I think. So yeah, they have label. So here I'm fetching one element. The output is this one. That is a function I have for handling this type of request. Gives me some information. I can set it up to return less information, but this is the way that it works by default. And here, for example, I can create a new path. So I can say transfer path. I would say it like to output. No, I would name it fetching data fetch. So when I go to these other models, you will see, for example, that this is initialized in data fetch. And here you have the whole chain of things that was done to execute these two models. But so I will, this will be the A, and this will be the B. So as you can see, if I initialize this, I have the same information, but if I do this data fetch, it will be initialized inside that path. So I will access directly to items. This is pretty cool because you can output things in many different ways, and you can do things like this. So I can take this. I will put first. It will be last, and this will be first. And I will take this here, remove this. As you can see, I have first and I have last in this component. So it's pretty handy, pretty handy, because you can consolidate data in different models, and then I can send this to another store, and the store has the same information, and I can just make this, for example. So I'm going to do this first, items 0, and I could just initialize this model with this specific element. It's pretty nice. So this is the way it handles pipes, and as you can see here in the model, it shows on top of it how it is being initialized with that. So I know that this is expecting that, but this is not forcing that the element exists. So I can also throw errors with this. For example, let's take this functional element, the orchestra, my favorite one, remember. send message, a critical error, just to, as you can see, as there is no error, nothing will be output. So this is not executed, it's just skip actually. So it's skip. That's the execution type of this element. But if I set some type of rule to define some error here, for example, I can say here I need. So there's two ways to trigger errors to set conditionals. Normally I see in the software that you have some module to do conditionals. I don't like that approach because it is so common to do conditional that it should be available everywhere, and it's a lightweight task to be done. In terms of code, it's just like it is not even executed if it's not like defined. So it's not like a big deal for the things that are involved in code. So there's various ways to interact with this. As you can see here, you can also bypass this and make that something always run, and I will explain why. That is pretty handy also. But I can say here, for example, the second path. So if there is no second path, it will crash. So module skip. So I can say also an error message, everything like that. But if I go here right now, where I saying the error, now it will run because the error was triggered, and also I have access to the previous information. So I can even use the information that was previously available, for example here, and use it in any other way to interact with data. So there's various ways to interact to get that data in the here, for example, but I can use it to do anything. So this is a pretty handy way to use it. And also, as you can see, when I set the second parameter, you can see here that these elements become conditional because I set a condition, and that condition triggers a chain of dependencies that make the process dependent on this element. For example, that this element is correctly executed. If I add here something, for example, this element before, this doesn't have that condition because that doesn't apply to that condition. That condition only applies to this and the rest of the elements. So it's pretty good as it works right now. This is the way it is executed. So the next thing is to show what each one of these modules does. They do pretty handy stuff, so I will show them in the next part of the video. So in this part of the video, I will show the different features that allows these components. Well, I think I didn't explain the previous video, is that to provide a conflict-free and safe way of executing this, every element that is executed requires at least to have one connection to execute. So if these elements are simply not connected, they will not do anything. As you can see, nothing happens. Nothing is executed in the whole chain. I need to organize this one because in other ones I added this tab to separate it, and it's pretty useful because this is only rendered when I set this state, and as the process gets bigger or there's a lot of data involved, this could potentially crash the interface if I just check it right here. So let me show you what the module does. So first thing is the dataset. Dataset is the only one that allows you to interact with this way with the request. It's just a request for the direct-use query parameters that they use, the regular parameters they use for doing queries. Most of the others models you will see they interact in a different way. This is auto-loaded from the directory, so if I do any changes to the columns or anything, it will be automatically integrated here and in the other elements. For example, I can go here contents as I showed in the previous video, and call a content, for example, in one, I set the fields, like ID. Here I have my ID, but I didn't connect it, so I have no result. And there I have my result. So yeah, that's one. This is pretty handy. I get information from different modules. Pretty useful. Then it's the request one. It has a lot of configuration, but it's basically a way to interact with HTTP request. I can set puppeteers and other stuff I have installed. I installed Crowley in this system, so I can run pretty complex puppeteers on websites where we also proxies and stuff. So where we show something really simple, like calling google.com. I can also store the requests and the responses if I need to have some storage of what I did. So I can just for example, here is the response from Google, and here's the headers, and yeah, it's just basic HTTP requests. It's handy because this can be run by other modules, and you can basically make all this dynamic. If you have some scrape or crawl or anything, you can do it here. And you can then here also I have various ways to set codes to identify stuff, because normally in this system where you are doing data transformation, you want to set some sort of like traceability and stuff. So I normally do some like fetch, for example, web fetch, and some sort of like notation to know what I did. So that's one. And then is this one, the generative AI. That is you can create prompts. This integration with TipTap, a custom implementation. So this is only for naming. You can say here like general instructions. If I go here, you will see here that the thing I wrote is there. So and you can set here, for example, this is a request, and you can set here, for example, items, and this will take the information from the previous. As you see here, I don't even need to initialize this, because these are initiators that I can use to select a specific scope to initialize those paths. But if I don't use them, I can still access directly to the path, as you can see right here. And for example, this just builds the request that you will then will send to a specific model. So for example, this is a question. This is in Markdown format, and this is in HTML format, whatever you need for your needs. So these are requests, blah blah blah, and this is for example, the initiator of the code block, and then you have the information. So when you sample things and you want to send some like information of reference, doing, for example, a augmentation by information retrieval, you can do it pretty easily. You can just get the data, format it, and normally the models interact well with that information. That is generative AI. That's just like I don't know if that's the correct name, but it just builds some prompts, and you can then build more steps. So it will get complexer, but it's just to organize the line of thought that you're trying to represent with the information you're doing. So that is generative AI. And Morph is interesting. So you can here get some kind of transformation. So the transformations that are being available right now to move information around is object to object, objects to object. So I can do this. I could initialize the items. I can set IDs for example, and if you kind of understand the notation I'm doing from a path perspective, it will generate this. So I am taking the ID from the element, from an array of elements, and I'm sending it to a path, and this path is the ID's path, and actually I'm doing this like a push operation in JavaScript for example. I can also do this and we'll add it to the beginning of the array. So it's pretty interesting because you can do whatever you want with this. So, and then you can do a lot of other stuff to do that, and you can transform the data and just move it around a bit. So there's this one, object to objects, object to objects. So if you want to send one object to an array, you can also do that. You can do object to object, from like to just transfer information between different objects, and you can do objects to objects, all to all, that is basically proliferating information that you get. You send one instance of data to all the other elements, and all the other elements to all the other elements. So it's handy, that one. When you want to make, for example, I don't know, you have related items and you want to make some array to have the information of each one of them, of how they are related, you can do that pretty easily. It's tedious to do that with code. It's not difficult, but it's tedious, so I integrate to that. I think I will be adding a lot more other types of transformations, but it's a pretty handy way to interact with data. Then there is Chronos, as you saw here in the previous, when I was showing how they are initialized. So just set a date here, for example, and set, for example, some time frames. You can set the format, a lot of other stuff, but basically what it does, it just creates time series for you. Other one is, for example, method. Here you can this is an interesting one because, for example, Orchestra and method chain has like a life cycle of how you can do the things with the data. Source batches will be method source items. I can say to 3, and this will make it work. So as you can see here, this converted the array that is here into different batches, so it works. The last one, as they were just 10, it's just one, but if you need to do some kind of operation and just chain them and do anything, it can be done. So it's pretty handy. But as you can see here, I can just access the source code, the source of the where is the data and the method. Here in the next one, I can access also each item. If I'm running this on a specific, if I initialize this in the simply in an array. So when you do this, you actually always have to do this. You have to ensure that this is an array. You can say that here or here, but or you will get an error and the process will stop. That is not a big issue, but it's normally recommended to do that, like to put some conditional and to actually inform what is happening. So here you can be really expressive about the error and set some sort of like logic to let the next module know what happened. So that's what. But this is a lot better. Orchestra is a lot more powerful. You will see instantly how it works. So I've been testing it with a lot of other with a lot of other situations. So the Opera one also has access to the source, but also can intercept the information. So on each item and in the whole execution of the data, you have this go notation that you can set if each item of the whole data can continue or not to the next step. So it will just clean it basically and remove it completely from the moving data. Also, you can set a pipe. So on each iteration you do, you can start sending things to pipes. So if I have some data here, I can take the data from these let's say items here, for example. Wait. So here I have access to items, and here I can start sending the items to different pipes. So you can send pipe test 0, and we'll do that. So it will add them. So I can do this all the times I require for it to be done. And so any element I can send it 5 different times to the 5 different pipes in 5 different instances, or remove it. So to manage the logic to handle candidates is pretty handy. The only bad thing about this sort of execution is that it always runs through each candidate. So yeah, you can be cleaning them on each iteration, but for example, if you are on 1000 in the first iteration, you clean 100 the second one. So if I here add another one, it will run in the 900 left that are available in the iteration. So yeah, you can do some like candidate cleaning, but it's still not the most efficient way to handle, for example, datasets that could be or like data that you want to handle that could be like 100,000, something like that. It's not the most efficient but way to do it, because you will normally in those cases will like to add some sort of way to handle it more efficiently. For example, if you are searching for something, but it's still a great way to in I don't know, not so big or a big amount of data, to just handle it really easily and do modifications. So yeah, I still believe it's a great model. I use it a lot actually because of it. And well, here you can also change the priority, so you can resort the array pretty easily. Each iteration it resorts based on the sorting you set, and you can set also factors to change with a multiplier how it's sorted, or even with like a find sum to add or subtract something to move it to the front and to the back of a sorting list. So, and you can have access here to other things like the first element, the last element, and some properties to know if it's the first, if it's the last, what the data of the previous one. So you can do really fast operations when efficiency is not so important, and the most difficult part is just the logic of how it's organized data. This I would say is one of the greatest models of the system. Then it's the store. Store is pretty simple. So it's a model that you store data. You check the data moving around as this one, and you can then, for example, set this here to file test video. I will say it. So to JSON, I don't want the configuration of the whole chain, I just want the information. You can also store the information on the whole chain if you are doing debugging, to store that information. And this strict name, it removes the timestamp, so it could work like a memory. So memory testing, I would say. So here, as you can see, you can also set some data to give more information about what is being done. Testing the memory storage, JSON format. So we can have the information there. So, and this that we will do, we show you the same information, okay? But now, if you add another storage, this one, you can go here and start loading files. So you can load this information. You can set it to ABC, for example, and you have the ABC and the data that you got from the previous. So it's pretty useful for handling memory, like, and it's pretty handy. So I can rerun this, for example. I can change, for example, the order. Also add the label. I can run it. It's only that model. Also, this testing console just runs until the required that collection didn't have labeled. That's not a problem, but only runs until the model you requested, so it stops the execution. That's why I had to click again testing, because I was just testing until this. That is the first one, so that wouldn't create the memory. So then I disconnect, because as they are available, it could happen that it could execute that, because as they are two different workflows from a cyclic directed graph, it could be executed. So yeah. So you can see the memory works, and this is the same request, organized, sorted in a inverted way and with a bunch of new data, but it works. And it's pretty good. This is pretty handy. It's one of the most useful models for me. And then it's connector. This is too messy to explain, but it's like there's a lot of conditions, queries that you can use to connect data. It's pretty consistent. It's pretty good. Here in all the models also has this pass-through, that I have this schema to giving the interface some information to know what is expected to be added. This also copying the information, so I can just do this or this. So, and the last one that is really it looks like the Dataset one is this one, the integration one, that just integrates data. So you have an integration path, for example, items, and then you can do things with it. You can get, upsert, post path. The most common thing I do is upserting. I select a collection, and then I just can add arguments. I can pass through a lot of things. So it's a really big model, but it's good because when it's ready and done, you can just then duplicate the workflow and do amazing things in no time, basically. So it's pretty fast. So I got, for example, to design completely functioning and tested workflow about like 30 in 1 day. So it was pretty fast. So it's pretty impressive. And this one is pretty handy. So when you create a workflow, you can also call the workflow. How do you call it? So you just simply go here, select a workflow. For example, we can go to the core, connect collections, and this will do this. This looks messy, but it's not as messy as it seems, because you can just come here. You can just check what is the default value of how it's being tested, because it is a common pattern I use for the core modules, that I just set a default with a testing data set here, for example, as you can see. And these are, for example, testing IDs I'm testing, and then I here can just, for example, the same one, I set them up here. This is not as wide as I would like. I think I could do this panel a bit wider because a bit like stretched, but yeah, here I can give some information to the execution of the module of the previous step. So here I have the things I set in that form, and this just executes the workflow. So the good thing about this is that you can run a workflow with completely different parameters. You can change anything, collection, whatever you want. So you kind of design one workflow and then you just can reuse it the amount of times you want, the ways you want. So I think is one of the core things I do a lot. So you will see a lot this, for example, this Feedly workflow. I will continue with this in the next section of the video because to make a bit of a stop. So I made this shortcut between the video just to have the files organized. So this is a common workflow. This is how workflows normally look. So I fetch data. Normally I initialize some data and do some kind of helping utilitary module or something. I fetch more data. As you can see, there's a lot of like guards of paths that ensure that if anything is not available, it will completely stop the workflow. I will send the error, so that's pretty important. And then I have normally a lot of functional components that are just dedicated to super specific stuff. It's like organizing data. For example, this is the integration input that is expected for the last workflow. But this is really easy. So I'm getting the items, I'm working through them, I'm just getting some data I need to organize, and then build the map I need to. It is expected in the workflow. Then I set the metadata I need to organize it, but this is a lot less work that I normally just will require to do the same. And here I have these transitory storages that just move data around. As you can see here, I also have some connections, as this is like a cyclic directed graph. If I set this connection, I ensure this is dependent on these two elements. So these two elements that are here are a dependency of this element that's here. So with that, I ensure that the workflow works perfectly, that this needs to be solved, and and that is like a really common pattern of moving things around. Normally I also use a lot of storages to just separate information. As you can see here, this is consolidating information, and this is just isolating something for a specific purpose. Sometimes I just want to see in the console, but it doesn't require a lot of information, a lot of memory. I've done a lot of testing with that, and that is like a really common workflow. For example, these three modes are exactly the same. This one, this one, and this one, and this is the meat of the of the model. That is the integration that is being done. But it's pretty easy because if I duplicate this, I just have to change this a bit. It's not too much. It takes me I would say, I don't know, 10 minutes. And normally the errors, how they trace, is also pretty easy to handle. Normally I have to change, I don't know, one column depending on how I want to observe things. And that is one of the things that I have in my internal code, but it's pretty simple. And the last thing I want to show is this thing. So you're seeing this icon right here. This icon right here, what it shows is that this is the model that is returned to the response of this workflow. So if I check the console, or if I'm moving some output, for example, as this one, so for example, the one we were testing, this one. For example, this model. If I do this, it returns this. So this element, this output object, is what I can set completely with a lot of flexibility. I can set this here, for example. This is return. So you can see if I run this workflow, even though I can have a lot of things after it, this will be returned. And if I set this, for example, these two will be returned in an array, or if they have different paths are defined. For example, this is A and this is B. It will solve the conflicts to have an A and B in an object. So it's pretty handy to just ensure that the data is well done. The thing I haven't done automatically is detect all those things, because it would be nice to have another way to just do this, like to also inform in this model what it will be returning. With the paths should be easy, but there are some situations that the things that are being triggered are not in the so easily available as in this case. For example, in errors, if I set an error here, extracting information from here is pretty simple, but extracting that information from here is not as simple as this. So, but I think those are things that could be improved over time. And yeah, so that's mostly the way this system is works. So, and as you can see here, I can just try some I haven't been doing so many changes to these workflows, and I haven't seen them. I have another system that I work more with this system on a bigger scale, but I normally use that for making weird changes. And I as you can see here, for example, I have some workflows. This is a good example, the sync ones. For example, I have this sync from core, sync to core, the transformation that I also normally do this, like call information from a static API. For example, I have in my local network to send data to the core that is in that static IP. I will have to change that after the video, but and the same way for this, for example, I can just call the data from the core and integrate it here. So I normally do that. So, but I can just start all the process I need from here. For example, I could just start those ones. That's a thing I need now in the interface. I will add soon a way to just start the processes, so I can go back here and they will be running, and we can see them here. They will have some errors because some of these processes are dependent on other ones, but as you can see, they are working, and they work pretty well actually. So, and I can be running, I don't know, in my main computer I'm running about like 60 processes at the same time without any problem. And yeah, that's the system. So lastly, I wanted to talk about some challenges involved with this software. talk about also about the runtime of this. I'm running it in a bigger computer with a lot of more cores than this one, a lot more memory. This is like a really compact laptop, MacBook Air, and in that system it is possible to run it concurrently as in nodejs, and DirectX also has the way to work with PM2. That is a good library to run Node in many cores. In simple, what it does, so you can select a specific course of your computer and run it with like a memory limit. So you can say that 2 gigs of RAM for each node to run. If you have like a beefy computer that can run it with that amount of memory and can handle like all that. And today there are processors that do that, so it's easy to scale actually. And then you have the part of the concurrency of the dataset, but I think the system will benefit a lot adding some priority mechanism to load balance automatically the processes. I haven't done it yet. I'm just using this logic right now and adjusting just the size of the request. For example, here you can see this is just working in this testing environment that is a lot smaller than the main one in a size of 40. So this is not much. This is really small, but that is also important, the priority thing. And also, even though you want to work with 400, 500, depends on the data transformation you are running, because you can trigger a lot of logs when you are working with ACID compliant datasets, the databases as MySQL or MariaDB or Postgres. So there are obviously a lot of strategies to deal with that, but still the system, even though having these tools or these features that could help it work a little better concurrently, there is a part that is completely related with how the data transformation is designed. For example, you need to in some way escape from the logs. So I was thinking about doing one model that is like an added model that it just show me in real time what logs are currently available in the database system I'm using, and with that I could just use it as a filter to not use them and skip them from the request. That's one way. But I think that's one of the most important improvements that this could be benefit by, because I just have improved a lot the code in terms of efficiency. I like check every part of it to see how it handles memory. And from the front-end perspective, I think there are also a lot of changes that could improve the system. The first one is that I see myself a lot copying stuff. So I have this one, I can do this, for example, and I do that a lot, for example, especially in system, in workflows that I need to replicate something, like, for example, capturing an error or changing the status of something, for example, in these ones. For example, these are pretty common way of, for example, this URL extractor. So I check some content and I get the URLs, and then I just store them in the database to just map the relation between the movement of information or the knowledge the movement of knowledge. And for example, as these are the same, this that model that just changes the processing status of something. So there is a collection that has this item. This item is connected to some status that is checking what has been done with the element, and I need to update it to check if there was an error, if it was completed, it was started, etc. So that's a pretty common use case. And as I see myself copying a lot of stuff from other models, I think it would be really nice for example, just select these things as you are seeing in the interface, and as I select them, just store them like a template. It would be like pretty handy, and then just import it. Like have here a button that says import, select from a bunch of different patterns and or templates, and just import it and use it. So I think that will make a big difference in the speed. I will start working that like as soon as I can. So as soon as I can. So yeah, those are the things that I'm working right now in this system. It is in early stages, but I think it's a pretty good solution. It is a good solution because I use it. I would say that because I use it a lot actually, and without this, for me, it would be impossible to do the project I'm doing right now, because it's out of reach of time availability. So it would be not even feasible from in terms of my lifestyle, my own responsibilities. But this is the system I built, so I hope you like it. And any question you have, you don't hesitate to ask me, and I will answer you the sooner I can, as soon as I can. So, thank you.